All right, so I'll start with question one. We'll just go through the questions one by one and then see how many we can get through, okay? If you have any questions or if you don't remember something, if you don't remember the stuff, just tell me.
Wait, wait, when did we do this?
Did you not do this?
I think I missed one of the lessons. Hold on.
Ah, okay. Sequences. Maybe you missed this. 2, 4, 8. So anyway,
Yeah,
do you remember arithmetic and geometric sequence?
I remember arithmetic, but I don't think I remember geometric.
Okay, geometric is rather than, well, what's arithmetic? Tell me.
Isn't it like 2, 4, 8 continuing like that?
There's a definition.
Um, a sequence that continues.
Don't guess, don't guess, don't guess. It's not 248, by the way. 248 is geometric.
Ah,
Okay. One,
ah,
two,
wait.
three, four. Constant
Yeah.
difference
Okay.
is arithmetic. Oh wait, let me actually do this properly. Wait. Yeah, so constant difference is arithmetic. And constant ratio means you multiply by something, right? Or like when you divide the two numbers, it's a constant. So constant ratio is geometric. Okay?
Okay.
Did we do this before?
I don't remember.
Okay.
Maybe.
It doesn't
Yeah.
matter. Let's try it out. If you don't remember, we'll just skip this part because the arithmetic,
Yeah.
this is constant difference, okay? Let's say 2, 4, 6, 8, blah 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 blah. So it's constant difference plus 2. Okay?
Yeah.
Geometric is 1, 2, 4, 8, 16, da 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 da. So there's a constant ratio.
Yeah.
Okay?
Mm-hmm.
So now identify the sequence are, yeah, for the following sequence, identify if they're geometric or arithmetic.
Okay. First is geometric, second is arithmetic, third is geometric, and fourth is sum of 3 times 2.
There's a neither option, by the way.
There's a what?
Neither.
What is a miter? Huh?
Neither.
Neither. Oh, wait. One is geometric, right?
Okay, what's the
It-
ratio?
Wait, let me rethink this one. I swear it's um is it like multiplied by 2, multiplied by 3, multiplied by 4, multiplied by 5?
No, that's not constant. Constant means same. So this is multiplied by 2 and then multiplied by
3.
3, so it's not geometric.
Oh, what?
Obviously not arithmetic, so it's neither.
Wait, then what type of sequence would that be?
It's neither.
Oh, neither. Okay.
The second
Um,
one, yeah,
Surely that's arithmetic, right?
yeah, that's arithmetic.
Then the third one is geometric.
We haven't got to that part yet.
Okay.
Oh, by the way, the sequence has a very weird stuff at the end, right? Normally you just put numbers, but this
Uh-huh.
U10 means the 10th term, okay?
Okay.
And S8 means the sum of the first 8 terms, okay?
Mm-hmm.
So it's also saying that it's saying the 11th term, which is U11, it's saying this equals to S8. This is the sum of first 8 terms, okay?
Okay.
All right, so, and it tells you this equals to 10. U10 equals to 2.
Okay.
Oh, by the way, this might not be arithmetic. Because
Oh.
it's okay. We just assume that this U10 is correct, right? It's like -15, -14, -12, and then whatever, right?
Mm-hmm.
Like, but we also have to verify. If it's not what we assume, then like U10 being there is not correct. You get what I mean?
Okay.
This is like a trick question. Normally, they would just ask you whether this is a arithmetic, and of course it is. But I'm suddenly asking you, okay, the 10th term is like 2. Is it 2? If it's not 2, I'm saying the 10th term 2, then what I'm saying is not correct. So this is not a geometric sequence, right?
Yeah.
Sorry, arithmetic. This is what the question is saying. It's a very weird way of saying it, but hopefully you get what I mean. But let's just assume it is okay and try to verify it, okay? So 10th term is U10. There's a formula for U10, which is the first term plus 9 times the difference. Did you do this?
Nope.
Okay, you definitely didn't do this. Okay, we'll skip this part of the revision. Everyone else, maybe they can do the question. Anyways, this formula makes sense, right? Your 10th term, you got a plus 9 times the
Oh
difference.
yeah.
It makes sense.
Yeah,
Okay,
that
so
makes
the
sense.
difference is what? First term is -16, right?
Mm-hmm.
The difference
Plus
is
2.
2 plus 2, right?
Oh, plus 2.
So this gives us +2. So this is indeed the U10 equals 2. So that's fine.
Okay. Yeah.
S8 is a little bit hard. There's a formula for this, okay? It's the first term plus the 8th term divided by 2 times 8, okay?
Okay.
So this formula uses symmetry. It's saying the first term plus the 8th term gives us the average, right? And average times 8 is the sum, right?
Yeah.
You just gotta convince yourself in an arithmetic sequence, this indeed is the average of everything. Okay. I'm not gonna prove it right now because it's not that simple, but it's not too hard either. If you can get it, you get it. If you don't get it, we can just use this result. But we don't know what U8 is, so we gotta convert U8 to like U1 plus 7D, right?
Okay.
Over 2 times 8. So this is like times 4, right? Yeah.
Yeah.
So these two times 4. So different U1 is -16. So -16 minus 16 plus 7 times 2, which is 14 times 4, right?
Yep.
Oh, wait a second. Oh, I think I'm choking. Oh, wait, what am I doing? Nope. I mean, this part is fine, but the question, I misunderstood the question. Oh, so see this? Find the indicated sum and find the indicated term. Oh, so it's not saying that sum is part of the sequence. It's just saying we gotta find that term. Oh, I'm stupid.
Okay.
Why would they just not put this in the extra line? So confusing. And why does this tell you the answer straight away?
I have no idea.
Ah, that's a weird question. All right. Anyway, yeah, so that part, okay, I misunderstood the question. Sorry, my bad. So, yeah, I mean, yeah, we just look at the first few terms. So, yeah, don't worry about the stuff after that. All right, so what's the third sequence?
The third sequence is geometric.
Yes, what's the ratio?
Divide 2.
Nice. Multiply by a half. Okay.
Yeah.
When we talk about the ratio, we always talk about we have to multiply by a half because the formula uses the multiply rather than divide.
Okay.
What about the last one?
Um, so the sum of
Technically, this is a very poorly stated question. The sum is a sum. It's a
oh,
single number. It's not a sequence. But I suppose it's talking about the sequence. You really didn't go to this question, this lesson? Because I remember specifically talking about summation notation to you guys.
that's sum. Oh yeah, I remember hearing that, but I
Oh,
think
you
I've
must have came to this lesson before. Oh no, maybe it was binomial. I don't know.
X sum. Oh, is that an X? Oh, it's infinite.
times. Yeah, so this is sum. When n is 1, this is 3 times 2 power 1 minus 1, 2 power 0, right?
Yeah.
3 times 2 power, oh wait, no. Plus 1 plus. The sum means this, okay?
Wait, is that going infinitely?
Infinite, yeah.
Okay.
Of course it goes to infinity, but the question here, I don't think it's asking for the sum, it's asking for each term in there.
Damn.
So let's say the sequence, suppose the sequence is this. Is 3, and then 3 times 2, which is 6, and then this is 3, 12, dot, dot, dot. Of course this is geometric, right?
Okay, yeah.
But if we look at the sum is just one number, it's not saying anything, right? So this is a very weird way of phrasing it, and it's inappropriate, honestly. It's like a bad textbook example. Yeah, so university math student, we have this picky way of looking at stuff. Technically, I'm gonna say, technically this is questionable, right? But I suppose it's indicating geometric.
Okay.
But it's not a sequence, it's just sum. It's a, yeah, whatever. Consecutive five, the consecutive multiples of five greater than this. Is that which one is that?
Consecutive multiples of 5 greater than. Uh, what does it mean when it's like consecutive multiples of 5? Is it like.
So multiple of five is 1 times 5, 2 times 5, 3 times 5.
Yeah.
That's consecutive multiples of five.
Oh, I have no idea.
Okay. Greater than 104, then the first one will be 105, right? 110, right?
Yeah.
115. So you gotta state the question in your head first. Is this sequence? And it's, of course it's arithmetic.
Okay.
Okay, you gotta understand the question. Once I write this out, it becomes easy, right?
Yeah.
This is literally the consecutive multiple of 5 greater than 104. Okay.
Greater than 104.
All
Oh,
right.
okay, I get it.
For uh for the for these ones where it's neither. Okay. For the ones we have identified, find the 10th term, ninth term, and the fifth and the 7th term. How would you do it? Any idea?
Which one?
Okay, so right now we're looking for an indicator term. Find the indicator term, indicator sum, find a general expression for UN. Okay, we're gonna skip B. Let's do C and D, okay?
Yep.
So for 2, you gotta find what is it saying? Find U10, but it's already told you U10 equals 2. I don't know why they did that. All right, for 3, you gotta find U9, the ninth term. Okay?
Okay.
Okay, try to find it. And then for 4, you gotta find, okay, for 4. Okay, let's say for 4, you know this is a sequence like this, right? For 4, you gotta find U5, which is the fifth term.
Yeah.
And then for 5, which is the last one, it says you want to find U7, right? Okay, so it's just these terms.
Okay.
Yeah. I'll give you like 2 minutes. You can do it using the formula I told you, or you can just hardcore write everything out, because it's not too hard.
I think I'm a hardcore write it out, because
No, like the sum, the arithmetic you can formula. Try not to use calculator in this case. It's not that hard.
oh, I'm not gonna use calculator.
Yeah.
Um, you wait, isn't it saying to oh wait, I read the wrong question. Wait, so 2000 would be U1, right?
Yes.
Okay, I get it now. Wait, Michael, for 4,
Yo.
does that say n minus 1?
A 4 says yeah, n minus 1. Or you can
Okay.
just use what we've written out.
Yeah.
Yeah. Yo, Ryan, you know I'm going to Queenstown next week.
So go ski or something.
Yeah.
Damn. Okay, I finished.
Alright, what'd you get for you and I?
U9, I
Like
got,
question 3, yeah.
I'm pretty sure I got this wrong because 7.8125?
Maybe not, okay. So you and I just gotta keep dividing by 2, right?
Yeah.
So we kind of have a formula for this, which is 2000 times a half. This is your ratio. How many times you gotta divide by 2? 8 times,
9.
right?
Wait,
2 to the power of 8.
8. Yeah.
Okay. So this is what's 2 to the power of 8? I believe is 10 is 1, 2, 5, 6, right?
Yep.
But now you gotta do something like this. 1000 Yeah, I mean 2000 you can do some cancellation. Probably divide top and bottom by 8, you get 125. Wait, no. Yeah? No. Divide by 16, you get 125, right?
Yeah.
You get something like this. You get 8.
8.
What did you get?
7.8125. Because I just
Sounds about right. I'm not 100% sure, but like the magnitude is roughly right.
I
It's not
just
even
grinded it out.
Huh?
I grinded it out with the
Lamau, yeah, okay, it's
divide
probably
2,
right. Like
divide
he's
2.
calculated to verify it's this number. I mean, bro, just use fractions. Come on.
Yeah.
Okay, U5, what's U5? Question 4, U5. Oh, what's this one? What did you get?
U5.
Yeah,
48.
nice. What about U7 for last question?
135.
Yeah, 135. All right, so I didn't like since we haven't been through everything together, we haven't gone through everything together, you don't know this, but the formula for the general term is easy. Let's say you got nth term for arithmetic sequence.
Yeah.
The formula is just u1 plus n minus 1 times t, right?
Yeah.
For geometric sequence, very similar. This is u1 times your ratio to the power of n minus 1. So you multiply by this n minus 1 times. Here you are adding by n minus 1 times.
Okay.
So adding d n minus 1 times. This is multiplied by r n minus 1 times. That's what the formula is saying, okay?
Uh, okay.
It's been 30 minutes, and then the second topic is functions, okay? Functions slightly easier. Let's have a look.
Wait, can I see the geometric sequence formula again?
Oh, yeah.
So equals U1.
There's more to the sequence chapter I haven't told you, but yeah, using this
Yeah.
formula, you can deduce in and R. Let's say if I tell you two terms, let's say if I tell you the 10th term and the 20th term, you can use the formula to deduce N and R, no, N and D or N and R, right? Two variables, two equations. Do you get what I mean?
Yeah.
So once you know the formula, you can do a lot of algebra stuff with it, but you don't have to know because you're not doing this at school yet. When you do this at school, you'll find the practice today useful. Okay.
Yeah.
All right. Second part of the revision, functions. I don't know. Has Hannah replied me? Hannah, I don't know if she's coming. All right. Give me 1 second. Right. Chapter review. Exam style question. Hmm. We're just gonna do a little bit of practice. I can't be bothered too much with graphs. Oh, you know what? This is actually useful. So yeah, let's do everything. You know what? Can't be bothered. Let's do these. Wait, this is the question we're gonna do today. Cool. I don't know if we've done this before, but yeah, let's do these first. Have we done this?
Functions. I think so.
We've done functions, but have you done these specific questions?
No.
Yeah. Okay. No. Okay, all right. So functions, we haven't done inverse functions, but I'll briefly talk about it. Start from 3. Use the function to evaluate these numbers. Go from A all the way to I, okay?
Yep.
By the way, G inverse, if you can't figure it out, I'll give some hint. Because we need G inverse. Oh, by the way, what's G inverse? Just, I think we've talked about this briefly before. Not in detail, but what is G inverse here?
G inverse. Nope, I have no idea.
You
Wait,
times by
two.
-2, then inverse you undo. What do you do?
Oh, you
Undo, you undo.
you undo it
Yeah.
by multiplying by.
No, g multiplied by -2. How do you undo that? You divide it by -2, right?
Oh, okay.
So it's -x/2. Okay.
Wait, what happened to the whole G thing then?
Oh, the inverse function is undo what g does. It's another function, but we call it the inverse of each other. So they undo each other.
Okay.
So let's say g of 1. What is g of 1?
G of 1.
Yeah.
-2.
Okay, -2 times 1, -2. What about g inverse of -2?
It's 1.
Yes, 1. So they undo each other. Okay.
Oh, okay.
All right.
Oh,
So
yeah.
now you know g inverse. You can figure out everything by just substituting. All right.
Yep.
All
I'm
right.
just write this down. And everything. Wait, am I doing
Yeah.
everything?
Just question 3. Everything. A to and then we'll move on and then I'll explain more. Just do question 3 for now.
Oh,
Hello?
yeah.
You, you said anything?
No, I was just looking at the third function where it's like hx equal -4.
Oh, in that case, for whatever x, you just get -4. It's a horizontal line. It's like y equals -4.
Okay, I get it. I get it.
What a beautiful drawing I have right there.
Minus. Wait, Michael, what would 2f mean?
2 times the output of the function.
Oh. Oh. Okay. Wait, Michael,
Yo,
for inverse, you just have to like you just make it so there's only x on the other, like divide by -2, right?
you can just use the inverse function. Right now, you don't have to think about anything. I already found the inverse. Just use the inverse function.
Oh, okay.
Just use this,
Yeah.
right?
Okay.
Let me prepare the next one. Next one is linear graph. Yeah, let's not do linear graph. Let's just do quadratic straight away. Hmm. Oh, this has linear graph and quadratics. We might not do binomial. Depends on how much we get done.
Wait, Michael.
Oh shit! Wait, sorry.
For question H,
Yeah.
I got like 4x squared minus 6.
Sounds right.
Wait, actuals?
Yeah, you
How
just
do you know?
substitute. Just substitute. It's called composite functions, but you're not putting anything inside the function. So you're trying to find the general
Oh,
form of the composite function. So you just put the gx inside fx to what you get.
yeah, okay.
So in this case, you're just treating x as the input and carry it all the way across, if you get what I mean.
Also, what is that circle for I?
Same as composite functions. Treat this as like bracket,
Oh, same as composite. Okay.
like this. Oh my, did we do log before? I'm not 100% sure.
I don't think we did. Oh, wait, no. We went over it briefly, I think.
Ah, okay. Today, like this term, I feel this term is very rough. We didn't really go through anything in like great details. I
Mm,
think if you guys all want to do next term, I'll keep going. And then next term, I think we'll just go really details, and then like I'll make you guys vote on what to do every week.
okay.
So it's best related to what you're doing at school.
Yep. Okay, I'm done.
All right, what did you get one by one?
First one, I got 3.
F3 equals to 3 squared minus 6, which is 3. Okay.
Second one, I got -2.
F minus 2 equals minus 2 squared minus 6. This is minus 2. Okay.
Then I got 12, I think, for the next
Okay.
one. Then -9 for the next one.
Give me some time. How much? -9.
Yeah.
Good. Okay. E.
2. Let me find it real quick.
Yeah, always keep a track of your working.
Yeah, hold on. 2FO times 2 is -12. Minus 2G minus 1. -4.
No.
Wait, no. Well, I got -12 minus
Yep.
2G open brackets minus 1. And then
What's
G
G -1?
minus 1 is
What's
minus
G
2.
-1?
Minus 2.
No, it's +2.
Wait, why?
G -1. What's G -1?
Oh, I mean +2, yeah.
Yeah, and then you got
+2
-2 times
times
+2,
-2, -4.
-4.
So it's -12 minus 4. And it's
Did you say
-16.
-16?
-16.
Is that what you got?
Yeah.
Okay, my bad. I misheard.
No. I was looking through the working and I looked at the wrong working, so I only got up to the -4 part. And it was
Oh,
like,
okay.
and
Okay.
the answer was slightly below that.
Yeah, okay. F.
Which one is it? 20.
Give me 1 second. This equals to -4 times -5 is +20. Yes. All right, next question. Which one are you up to?
Uh,
G.
3/2.
Okay, 3/2. F of G. You said this one. I think those
4x
correct.
squared minus 6.
4x squared minus 6. Yes. What about, what's the next one? F of G inverse.
X squared over 4 minus 6.
Honestly, I don't even know. Let me have a look. What's our G inverse? All right, say that again.
X squared over 4 minus 6.
Yeah, nice. All right, that's the entirety of question 3. Give me 1 second to tidy it up, and then do you want a break? Or I think we can keep going because we got all the way to 6 o'clock, and then my God, my Zoom is lagging. Massive lags. Okay. Give me 1 second to tidy things up. All right, sketch the graph, but don't use your GDC.
My GDC, wait, what is that?
Don't use your calculator. You don't have a calculator anyway. Sketch the graph by hand. Try to do this. Do you know how to do? Do you know how to do this?
Let's see. Use your GDC to help
Don't
you.
use your GDC.
I don't even know what a GDC is.
Good. All right. Do this to x and y and try to fit some values like -2, -1, 0, 1, 2, etc. Okay.
Okay. Y equals. Wait, what do the two lines mean?
Oh, absolute value. Do you not know this?
No.
What's the absolute value of -2?
-2.
Oh, okay. Interesting. Interesting. You don't know absolute values. Okay. Absolute value means whatever inside. If it's negative, it becomes positive. it's kind of like the magnitude of a number. Okay. So it's commonly used in distance. When we talk about distance, we only want the positive value. So if we accidentally subtract the bigger one from the smaller one, we get a negative, but absolute value makes it positive. Make sense?
Okay, wait. So if you had -2 as an absolute value, it would be 2.
Yeah. If it's positive, you don't do anything. It just simply disappears.
Oh, seriously? Okay.
Yeah. So when it's x, you got to look at every value of x, right? If x is like negative, it becomes positive.
Okay. That doesn't seem too hard.
It's not hard. It's pretty easy. The concept itself is very easy.
Okay. And how many values do I need to do? Wait for.
Enough so you can kind of get the shape of the graph.
Okay.
So like these values I gave you should be enough.
Oh, okay. Oh my God. And what do I do after I draw the graph? State the domain and range.
Just draw the graph first, and then what did you get for the y values first?
2, 1, 0, 1, 2.
Uh,
Oh, wait, I need to square them.
cube.
Cube them. Oh, okay, wait, okay. I just choked.
Also, you got a -2 as well.
Yeah.
So we're not just talking about absolute values. So yeah.
That should be. Wait, so Michael, would it be the positive value of x cubed then
Then
minus?
-2, yeah.
Okay. Okay. Okay, wait. I need to do that again then.
What did you do?
Oh, nothing. Trust. I just need because what I did was I did the negative value of x cubed minus 2.
Not negative, like absolute value.
Yeah.
Yeah, that's fine. Yeah, your absolute value first and then minus 2.
Yeah.
Yeah. I mean, it's pretty obvious, right? You do the cube first and then the absolute value and the minus 2.
Mm-hmm.
I don't think this is yeah, I don't think it's ambiguous.
Okay. Let me just plot it down now. Wait, what the goof? This is such a weird. Why does it look like this? Oh, okay. What do I do after I plot the graph?
You tell me the y value first.
6, 1, 2. Wait, 6 minus 1, 2, 1, 6.
It should be symmetric, I believe.
Wait, minus 1 cubed is
Minus
1.
1. Minus 1.
Minus 1, but then it's absolute, so it's 1, right? Then
Okay, and the minus 2 is minus 1. Okay, that's correct. That's correct. What is this?
then
This
oh wait, and the second one is also minus 1.
it's minus 2 and minus 1.
Yeah.
Did you say minus 2?
Yeah, minus 2
Okay,
minus
okay. And
then
a 6.
6.
What I mean by symmetric, the absolute value means that the positive and negative doesn't matter. Okay?
Yeah.
Because it's converting negative to positive. Although there's a cube inside, but the cube like is it follows a pattern. Like if we have negative x, oh wait, what am I doing? If we have something like negative x cubed, this is actually the same as negative bracket x cubed. Oh, sorry. Negative x bracket cubed. They are the same, okay?
Okay.
Therefore, if we apply the absolute value, they're gonna be the same.
Yeah.
All right. Anyway, the graph looks something like this. The intercept is y negative 2. The graph looks like this. Okay?
Yep.
Very similar to a quadratic graph. Because of cubic, normally without the absolute value, it's going to look like this. That's a cubic graph. Okay?
Yep.
Because negative side goes down, but with the absolute value, it flips up and it's very similar. The shape is literally the same as quadratic graph. All right. And I ask you, what is domain and range? What is domain and range here?
Domain would be, wouldn't it be infinite?
Or anything we call real numbers. Okay?
Oh yeah, all real numbers.
So we do something like this. X is in real numbers. Okay?
Yeah.
What about range?
Range would be anything above minus 2, wouldn't it be?
Yep. So technically we could just say this, but like this proper notation, right? There's this proper notation we like to use. So if we use the proper notation, like we're talking about y. Okay, by the way, y, it should be y. Let me change it later. And such that what happens to y? So first of all, y is a real number. That's one restriction. And another restriction is that y is have to be bigger or equal to minus 2, sorry. Okay. Make sense?
Yeah.
So this is the proper notation. This is the proper set notation. It's not okay. It's the weird way of saying it because proper set is a thing. Proper set itself is a thing. So it's the set notation. Okay, set notation. Okay, in set theory, there's a thing called a proper set. So I'm not gonna use the word proper. Oh my god, university math student. Oh, such a nerd.
Damn.
All right, I think that's good. I'm not gonna make you do the second one. Second one's too painful.
Okay.
Or do you want to do it?
Nope.
All right. Okay, I mean this somewhere. That's question 4. All right. Question 5. It says verify that inverse functions, right? Yeah, verify or determine if that inverse functions. Okay. Algebraically, so you can't just guess and check like 1 and -2, -1, 1. You gotta actually verify it. Okay.
Okay.
And how would we verify? There are inverse functions if I'm actually not 100% sure if this is a strict way of verifying, but you want to do something like this: f of f inverse x equals f inverse of f of x equals 1. Oh, sorry, equals x. Does this make sense?
Okay.
So it is the same as what we did above with 1 and -2, right? But now
Yeah.
it's just in general. We're saying, okay, if we put the inverse function into the original function, we get x. And
Yeah.
similarly, if we put the original function into the inverse function, we also get the same whatever before, right? And I was wondering if this is necessary, if we have to do both of them, right? I'm not 100% sure if we have to do both. You know what? Like, let's do something interesting, okay? See, this is what happens in university. So you don't know something, and you go to ChatGPT. You go
Yeah.
like, does f bracket f inverse x equal x imply f inverse f x x? See, what I did was basically throwing the equation at him. I was like, yeah. So we said this equals to x, right?
Mm-hmm.
And that's the necessary condition for inverse function. I was wondering, do we have to do both, right? Or can we just do one? Do you get what I mean?
Okay.
So I did something like this before. Before I did something like, wait, let me put this on full screen. Hopefully there's no weird stuff on the left. Okay, I can put this in the notes. So before we did this, we did f of 1 equals -2, and then we did f inverse of -2 equals 1. So what we did before was essentially f x, right? And then we put this inside f inverse, right? We got this out. We did this before. But does this necessarily imply the other way around, which is we do the inverse before? Does this imply this, right? That's the question.
Okay.
All right, let's say what chat says, right? This is a great, chat is good, you're not good at this. No, it says no, not in general. Why? Two different property, maps back, domain, counter example, x squared. Okay. Oh, so this counter example is this is not an invertible function. If the function is invertible, then it definitely is. Okay. All right. We can just think about this in the graph. If function invertible, that means we don't have things such as x squared, because x squared gives us two values match the same value, right? That's not invertible. Okay. Okay, you probably don't know what I'm saying. Do you know what I'm saying?
Nope.
All right, so for function to be invertible, remember function definition, we have to be 1-to-1, right?
Yeah.
So you can't have two output with one input, okay? right?
Okay.
So a function like this is not a function, okay? Or we do something like this. This is a function, yes? Wait. So we have this function. This is a function. But if we have something like this, it's not a function, okay? Because
Yeah.
look at the mapping. This is one input to one output, but this is one input to two different outputs, okay?
Yeah.
But for this quadratics, it's not invertible. So if we want to inverse this, if we want to inverse the quadratics, right? Here. It's input output swapped, so it's flipped along the diagonal axis. It becomes this, okay?
Yeah.
So this is the key of inverse function is input output swapped. So x and y axis swap is flipped along this axis, okay? And now if we look at this is no longer a function, okay? So although y equal x squared is a function, we say this is not invertible, okay? Because when we flip it, it becomes this, and this is not a function, okay?
Yeah.
So if f is invertible, then yes. So if f is not something like this, if it's like a nice line, maybe like f looks like this, right? When we flip it, it looks like this. Yeah, of course it's we don't have to verify it both ways. Yeah.
Okay.
If you don't get it, it's fine. That's a little bit too complicated, but I mean, in sum, all you gotta do here is wait a second. In sum, all you gotta do here is do this. Wait, here you don't get any x squares, do you? Oh, you do have an x square. Okay. You gotta do it both ways. You gotta do both ways. Only for this one, only for C. For A and B, just do this. Just do this and see if you get X, okay? Actually, you know
Okay.
what? I think I'll just make you do A and B because we gotta do other stuff as well.
Okay.
1 second. Give me 1 second. 1 second. I'm gonna put something in the notes. Put this in the notes. All right, cool. All right, only do A and B, okay? What?
Wait, so I have to inverse one of them.
No, the inverse says G is the inverse already. It wants to says like verify if G is the inverse.
How do you know if G is the inverse one?
Using this, putting this into this formula. So if you do this, and if it equal X, it will tell you G is the inverse.
Oh, so you do like if X.
Or you can find the inverse and compare if they're the same. Either way is fine.
Find the inverse.
Okay, just like ignore G and find the inverse of F, or you can check, or just find F inverse
If
and
inverse
check.
is X over -4, is it not?
Wait 1 second. And check if F inverse equals G. Okay?
Okay, well, I got it. That's so much easier. I'm gonna do it that way then. So It's wait, shouldn't inverse f be x minus 2 divided by -4 and not x minus 2 divided by 4?
Sorry, say that again.
For a,
Yeah.
f inverse, isn't that -2 divided by 4? I mean -4. X
Yeah.
minus 2 divided by 4. I mean -4. But for
Yeah.
g, that's x minus 2 divided by 4. So they are not.
There's a negative sign in front of it.
Oh, I'm so blind.
Okay.
Okay.
So this is fine. This is correct. What about the second one?
Second one. Half x minus 4. Wait, that's x times. Wait, Michael, the second one, they're not inverse, are they?
Let me see. Probably not. Maybe. I don't know.
Okay.
I'm still looking. Probably not.
Yeah.
We can verify. We can verify, right?
Yeah.
So for the first one, definitely yes. For second one, for B, so F inverse equals to you undo everything, right? Well, so you undo everything, so that's you minus 4, so you plus 4 first, right?
Mm-hmm.
And then so whatever you do at last, you undo it first, right?
Yeah.
And it's divided by a half, okay? So this is 2x plus 4, and I don't think that's the same, man. Honestly, I couldn't convince myself if it's the same. Yeah, it's not the same, okay?
Yeah.
Because normally the second one is linear equation. You convert it to the same format, okay? So this is 2x plus 8. You convert it to the same format. But for g, if you want to really verify it's the same, you convert it to the same format, expand everything, right? This negative 1/4 x plus a half, okay? So you convert it, once you convert it to the same form, you'll know, be like, oh my god, this, you compare this value, and this value, and this value, and this value, they're different, okay?
Yeah.
All right, let's not do C. Let's just call it here for functions. All right. Want a break?
Yeah.
All right, 5 to 7 minute break. We can go to half past and then we'll finish the rest. Okay.
Okay. Yeah.
Want to talk about the girl?
Nope, I'm good.
Oh,
I
okay. How's it going?
will be fine.
It'll be
It's
fine.
fine.
Okay. That's fine. Okay, good, good, good.
Yeah.
I'll tell you something. Me and the girl got together.
Damn.
We I bought her a necklace,
Okay.
and then we were watching the sunset. I wasn't prepared.
Wow, that's
I
romantic.
I was prepared, but like she was not. it was not meant to be like the official proposal to start a relationship, you know? And then, but I brought it with me. I was like waiting for the perfect time, right? Because you don't just buy it and like yoink it to her. That's like not as effective, you know?
Yep.
You gotta spend the money on the edge of the knife and then like cut it in the most efficient way, you know?
Yeah.
So
Okay.
like she was like, oh, it was kind of we were gonna go gym, but we were too tired the day before, so uh she was like, oh, let's just go watch sunset. I was like, okay, if the sunset is great, this is gonna be a good chance. So I had that little box with the necklace in there inside my pocket the whole time. And then when it was like the perfect time, I was like, yoink. I even wrote a plot in
Damn.
my head, and we ran through the plot, and it was crazy. It was perfect. And now I am officially non-single.
That is very romantic.
Yes, it is. You want to see our photos?
Sure.
Bro, you know this recording is gonna go up on YouTube, and one day people might watch it.
You okay?
I don't mind. I mean, I'll show you some cool photos. Oh, this is a nice photo.
I can barely see.
No, you can definitely see.
Oh, okay, I see.
All right, let's see. The photo on the day of the sunset, you want to see?
Sure.
Yeah, you can barely see this one.
Okay.
Is there a group photo? Come on, there have to be a group photo. Oh, this one's cute. I need a shave, man.
Okay.
Okay, we were looking at each other, but like couldn't really see. Oh, we see it. Okay. And then I like this one as well. Okay.
Okay. Okay. Okay.
Uh, I'll show you one last one. Oh, I like this photo. Oh, that's the day before I confessed, but I really like this photo. Wait for the camera to zoom in.
That one I actually like can't see.
Now?
I can't tell what's what. I can only see the face of the girl.
Yes, in the car.
Oh, I thought you were there as well. I thought you'd be in the photo.
No, it's just her in the car.
Okay.
All right, that's it. Yeah, little break.
Yeah.
All right, one more minute.
Yeah.
All right, let's move on.
Wait. I'm sorry. I'm in the middle of a Clash Royale game, bro.
All good, all good, all good.
I gotta lock in. I need to
All
win
right, all
this.
good. All right, I'll be right back then. Good luck.
Yeah.
How many trophies?
Like 7,000.
Damn, not bad. Okay.
Yeah. Okay. I finished. I won.
That's a huge problem. I like old rubbish that I haven't thrown, and like the bottom is like it's so bad already. Oh, I'll give you the new questions. You do it, and then I'll throw the rubbish because I can't keep this in the room anymore. Sketch the lines, sketch the intercepts. Okay. Uh, do one and two. Do one and two first.
One.
For one, if you are confused, especially with this one, find this. Do the set of x y value first. Do this first. Okay.
Yeah.
Okay. All right. I'll be back 2 minutes. All right, Ryan. How are you doing?
I am almost done with C.
Nice, nice, nice. Okay.
Okay, I'm done.
All right, do question two.
Find an equation.
I'll draw question one in the meantime, and you can check yourself. Okay.
Yeah.
Uh-huh. Nope.
Wait, all of two?
Yep. Why not?
Oh, okay, I got it.
All done?
No, I'm on B.
Okay, okay, okay. Oh, two shouldn't be too hard. All right, I don't know if we have time for exponentials, but I guess we'll just do how much we can, okay? Good work being done. Your math is getting boosted.
Plus 3 and has y-intercept of -5. Um, let's see. Oh, that's easy.
In the meantime, oh yeah, check your one as well, okay? After you finish two, check your one, okay?
Yeah.
Which one you on?
D.
Alright. Oh, D is easy.
Isn't that just...
Alright.
Wait.
Are you done?
Hold on.
Okay.
With gradient 0,
Means
that
0x.
isn't that just like 1 point?
It's flat line.
So there's no x, and it's just a...
There's no x, but it's not just
It's like a
it's a
flat
flat
line.
line.
So wait, wouldn't... Oh. Huh?
Yeah.
Wait. It's just -4, is it not?
Yes, related to -4.
Wait, y equals -4. That's the y-intercept, right?
Yeah, that's it.
Okay.
It's just y equal -4. It's a flat line.
Yeah.
Rate my outfit, Ryan.
Is that for date night?
Huh?
What's that for? Interviewing or date night?
Course date. I
Huh.
want to wear this while I'm teaching at home.
Mm. I need to get a
Alright.
closer look. Okay. What happened to the tie?
No tie. Casual, smart.
Okay.
We're not even going to a restaurant. I'm just going to our house and we're gonna make some food together.
That sounds so fun.
Alright, yeah, since I said the last one is just
Yeah.
so first of all, gradient zero is y equals 0x plus c. And you kind of know that you substitute this in, right? Y is -4, x is it's 0 already, so x like -3 doesn't matter, right? So c equals -4, okay?
Yeah.
But if you're like not smart enough, if you're familiar enough with this kind of stuff, you know that, I'm not even using, I feel like something's off. I wasn't using the right writing. All right. Y equals 0 times x plus c, and you substitute, sorry, 0 times -3 plus c equals -4, okay? But if you're like, well, look, you know it's a flat line, right? It's a flat line.
Yeah.
It's a flat line across 4, right? Let's say this is -3, oh, sorry, this here. -4, -3, right? You know it's a flat line across here.
Mm-hmm.
So you know you can tell this is y -4 straight away. So if you can picture it, you don't have to do the algebra calculation. Algebra is kind of unnecessary here.
I was trying to picture it, bro.
Yeah, no, good try, good try. It's okay. Like you're just learning along the way, right?
Yeah.
All right. I will try to do the points. Okay. So I always like to use rise over run. Okay.
Yeah.
So y equals mx plus c, where your m is rise, which is your change in y, which is -3, over run, your change in x, which is positive 12, right?
Mm-hmm.
So this is -1/4 of x plus c, okay?
Mm-hmm.
So we've known the gradient. Now we know the gradient, we shift it to 1 point, right? Technically, since we got the gradient from both points, shifting into 1 point means shifting onto the other point as well, right?
Mm-hmm.
So we just substitute some random points. So let's say the second one, right?
Yeah.
What does this give you for c?
C equals. Don't you just have to solve this like algebraically?
Yeah, I believe it's 1. Oh,
No,
wait, no.
it,
Is it?
it should just be.
It's 1, yeah.
Yeah.
Is that what you got? So the final answer here, this one is y equal -4. This one is y equals 1/4 x plus 1, right?
Yeah.
I'm gonna move this in sequence. We have like 10 minutes left. Oh my God. I think we'll do some quadratic practice because I think quadratic is very important. So I think we'll just do this and then we will go to some quadratics questions, okay? This question does A, and then what about B?
Which question?
Oh, no, that was A, that was A. I haven't went through B first. Line this parallel to the line this. So you know the line is going to take in the form of a half x. Parallel means same gradient plus c, right?
Mm-hmm.
But you got a y-intercept -5, so it's just y equals half x minus 5. Because you know this y-intercept, okay?
Yeah.
Do you know why c is the y-intercept?
Uh, yes, because it states the y-intercept is -5.
No, y is c the y-intercept. So like in general, y is this the y-intercept.
That's where The y, that's where the gradient passes through the y.
Where the line passes through the y-axis. Yes, but
Yeah.
why is that point?
Um,
Why is the c itself?
y to c itself. What do you
Yeah.
mean by
Like, why is c not the x-intercept, but it's the y-intercept?
that? Let me think. Because wait, why isn't it the x-intercept? Let me think.
Mm-hmm.
Wouldn't that mean there would be two x's on one side then?
I don't get what you're saying.
Oh, never mind, actually. So half x, that's gradient. And then the y-intercept. Why can't it be the x-intercept? Um, no, I have no idea.
Give me 1 second. All right, so why is c y-intercept? So there are two ways of seeing it. One way is c is so m is gradient rotation, right?
Yeah.
But without c, it's just rotating along zero. So c is the shift up.
Yeah.
So if we're shifting it up, how many units? C is like the y-intercept, right? Otherwise it's at zero. But if we are shifting it up by c units, the y-intercept goes to c,
Yeah.
right? Instead of zero. Second way of doing is algebra. So what's the y-intercept? Y-intercept is when you have x equals 0, what is y, right? So at y-intercept, your x is 0. And yeah, it's because on the entire y-axis, your x equals 0, right? You want to figure out where it intersects the y-axis, you substitute x equals 0. So you get y equals m times 0 plus c, which is just c. Okay, so this is your y-intercept. Okay.
Okay.
So there are two ways of explaining this. That's about it. Okay. All right. C, we haven't done C yet. C is what we want to see. C is line perpendicular. Okay. So perpendicular is negative sign and then reciprocal. Okay. Okay.
Yeah.
This is the perpendicular gradient. Okay.
Mm-hmm.
This notation means perpendicular.
Yeah.
What is C? You substitute the points. So C equals 1. Okay.
Mm-hmm.
And your line here should be y equals 3 over 2x plus 1. Is that what you got?
Yup.
Nice, nice. Good job. All right, 1 second. Let me tidy up everything. So this is, I'm gonna label this B, C, C, D. All right. Let's not do exponentials. Let's do a little bit of quadratics. Okay. Let's see. All right, let's just do a very general one. I don't know if you how many you can do, but like we haven't been through like quadratics in great details, but yeah, solve these questions. Okay.
All of them?
Yep. I mean, as many as you can do. Okay.
Oh, you know the three body problem that you
Yeah.
suggest I watch? Yeah.
The book or the show.
The show. I'm getting the book from my
Okay.
English teacher, and it's actually so interesting. Like, honestly, got me into physics, kinda.
It got you into physics. Okay. Okay. Not bad. All right. Time's about up. How many questions have you done?
I'm on the last one.
Oh, nice. Good stuff. All right. I'm gonna do the first four in background. Check if you got the correct answer. Okay.
Okay.
All right, we attempt factorizing for the last one. Okay.
Yeah.
All right, are you done?
Yeah.
Oh, tell me. To verify answers. I got everything on the screen.
Which one do you want?
Oh, verify all your answers.
Yeah, I think I got them right.
All of them. All right. So in that case, that's good. That's it for today.
Okay.
Any questions before we finish?
Nope.
That
I
was good. Good. That was very good. Very good. Very good. Very good. Practice.
yes, I love quadratics so much.
Actual.
No, I hate quadratics, bro.
No, that was fine. Like you did okay. Like all of those in like 5 minutes is good for you.
Okay.
Ooh, beautiful class notes. All right. That's it for today. We will not have this next week. It's finished for this term. When does school starts for you? When does school start for you?
Next week.
Next week.
We're
Okay.
having not next week.
Interesting. We're not gonna have a holiday break. That's very interesting. We might have a 1 week break, and then I mean next weekend I'm not in Sydney anyway, so I probably can't do next weekend.
Yeah.
I mean
Okay.
technically I can, but just like I'm in Queenstown, you know. But
Yeah.
so let's have one. Wait, when do you start? Like next month, next week, 7th, tomorrow, or like 15th?
No, no, no. Next week.
Okay, 14th, right?
Yeah.
Okay, so we start on 20th and then we'll see.
Okay.
All right,
Bye
see
bye.
you. Wait, we have a lesson tomorrow afternoon, right?
I think so.
Yeah, see you
Oh,
tomorrow.
wait. I might not be able to do tomorrow because wait,
Okay,
let's see. Actually, no, I can because what time is it in the afternoon?
like I think 9 for you.
9.
Yeah.
Oh, that's fine.
Okay,
I
that's fine. All right.
okay, yeah. Bye bye.
All right, see ya.